Okay, so now we're going to start taking up the questions on circular arrangements. Any homework questions? So my understanding it's 2, what else? 4, 5, 6. They're very hard, and I understand why there would be so many questions because most students have many questions on circular arrangements. Let's look at number 2. Now that says, in how many ways can 4 boys and 4 girls be arranged in a circle if no 2 girls sit together? Okay, so again we have a circular arrangement. There we go. That means the boys and the girls are alternating. So you have 4 boys and 4 girls. So we'll put boy, girl, boy, girl, boy, girl. 1, 2, 3, 4, 5, 6, boy, girl, for a total of 8. Always remember, whenever we have people sitting in a circle, the general formula we are using is n minus 1 factorial. However, when there are special situations, we need to modify this a little bit, or it might look a little bit differently when we do the question. When it comes to the boys, we have 4 boys to choose from, and once we place a boy, there's 3 boys left, and once we place another boy, there's 2 boys left, and then we're down to 1 boy. So can you see that that's 4 factorial, 4, 3, 2, 1? And then for the girls, we have 4 girls, and once we place a girl, it's 3, then 2, then 1. And they're alternating because the question tells us that no 2 girls sit together. No 2 girls sit together, so they must be alternating. Notice it's always a girl between 2 boys, a girl between 2 boys, a girl between 2, etc., etc. So notice there's 4 factorial ways to arrange the boys and 4 factorial ways to arrange the girls. But when it comes to sitting in a circle, we arrange relative to one person. So we need to fix one person, and then we can arrange the rest of the people relative to that person. So it's going to be 4 minus 1 factorial times 4 factorial, and that should give us our answer. We arrange one person, so in a sense then we have 3 factorial boys, 3 factorial arrangements of the boys, and then 4 factorial arrangements of the girls. And that would work out to be, I get 144. Okay, number 4. Now, in number 4, we're dealing with the keychain. So remember, a keychain, a necklace, or anything that can be flipped, we divide, the formula becomes n minus 1 factorial divided by 2. But remember, notice we have some identical items. So it's a little bit, so we're going to have to divide by what's the same as well. So that's an added complication to this question. So let's take a look. A caretaker has 10 color-coded keys for a building. Okay, so we have 10 in total. He has 4 red keys, right, for high security. A blue master key for each of the 3 floors, so I would say that's 3 blue keys then. A green key for 2 storage areas, and 1 brown key. So now we have a total of 10 keys, and they're all accounted for. So 10 in total, so we're going to be going 10 minus 1 factorial, and then we're going to divide by the 2, right, to cancel out the flipping, because when you flip they look different but they're really the same. So that's why we divide by 2. And then we have divide by what's the same. 4 factorial. I'll go like this, 3 factorial, 2 factorial. And then when I put that into my calculator, we'll end up with 9 factorial. So 9 divided by open bracket 2 times 4 factorial times 3 factorial times 2 factorial and a closed bracket. I'll just show you what my calculator looks like. It looks like that basically. That's what I'm dividing by, and that equals 630. Okay, let's look at number 5 now. Is there anything I can explain better on number 4? Let's look at 5. 5, 8. Did everybody get that? I don't want to block your view just in case people have. Number 5. In how many ways can an 8-person board of directors of a small company be seated at a table if there are no restrictions? So we're back to people sitting at a table, so we're using n minus 1 factorial. So they tell us there are 8 people, so this is 8 minus 1 factorial, which is equivalent to 7 factorial. And we get 50, 40. Part B. The president and the vice president must sit together. So let's draw a diagram. We have a president and we have a vice president, and they have to sit together. And then we have other people. We have 2 people, 3, 4, 5, 6, 7, 8. So in effect now we are arranging 1, 2, 3, 4, 5, 6, 7 things. So it's 7 minus 1 factorial, right? We could fix them and arrange the rest relative to the president and the vice president. But don't forget, it could be president, vice president, or vice president, president. So there's 2 factorial ways to do that. So it's 2 times 6 factorial, and that is equal to 1440. Okay. 14C. No, sorry, 5C. The company secretary never sits beside the treasurer. Well, the easiest way to do this is the indirect method, and the indirect method involves subtraction. So we could go total possibilities minus 2 people sitting together. Well, in part A we did the total possibilities, which was 8 minus 1 factorial. In part B we did where the president and vice president were sitting together. But if we're going to subtract when the secretary and treasurer are together, but that's the same calculation as in part B. And if I just flip over that, I know that was 2 factorial times 7 minus 1 factorial. And that is equal to 7 factorial minus 2 factorial, which is 2 times 6 factorial, and I get 3600. D. So in part D we have 3 of the directors must always sit together. So there's 3, 4, 5, 6, 7, 8. So if we look at this, we're arranging 1, 2, 3, 4, 5, 6, 6 things. So we're going to go 6 minus 1 factorial because we're still applying that formula where we fix one item we're arranging. In this case, it's the three directors that are together. I could have did it around this person. It doesn't matter. But you're fixing an item and then you're arranging relative to that item. But you know, if there's three directors together, there's 3 factorial ways of arranging them. So here are your 3 directors and you're arranging 6 things to arrange. Or in this case, 6 different types of 6 groupings of people, and then we will end up with 3 factorial, which is 6 times 6 minus 1 factorial is 5 factorial, and we get 720. So the other issue was with number 6. So we have 4 married couples sit at a circular table. In how many different ways can they be seated if men and women alternate? Well, that's just a different wording for question 2, where they say no two girls can sit together. It's kind of the same here, saying no two women can sit together or no two men can sit together. So the men and women alternate. So there's 4 married couples. So there's man, woman, that's one couple. Man, woman, man, woman, man, woman. 1, 2, 3, 4, 5, 6, 7, 8. 4 married couples. 4 times 2 is 8. So again, it's the same idea. You have 4 men, 3 men, then 2 men, then 1 man. And then you have 4, 3, 2, 1. Again, remember the rule, n minus 1 factorial. We have to apply that somehow because this is a circular arrangement. So we'll fix the man in this case. We could have fixed the woman. It doesn't matter. 4 minus 1 factorial. Then arranging the women, 4 factorial. And that's the same answer as in number 2, which was 144. Then we have, oops, now we have 6b. Each husband and wife must sit together. Okay. We have husband 1, wife 1. Husband 2, wife 2. Husband 3, wife 3. Husband 4, wife 4. And they have to sit together. So we're again, don't forget that formula. We're using this formula. We're arranging 4 groups of people, right? So it's 4 minus 1 factorial. But this could be wife 1, husband 1, and this could be wife 2, husband 2. It could be wife, right? So we have all these arrangements, and this could be wife 4, husband 4. So in effect, we have 2 factorial, 2 factorial, 2 factorial, 2 factorial. So we have 2 times 2 times 2 times 2 is 16 times 3 factorial is 6, and I got a 96. Six C. Each husband must sit opposite his wife. All right. Now they're sitting opposite ways. Husband 1, wife 1. Husband 2, wife 2. Husband 3, wife 3. husband 4, wife 4. Now they're opposite, see, so they're, oh, I'm sorry, they're fixed in this way. Oh, I matched up the wrong ones. They're going to be they're cheating on each other. But I think you get the message, right? So that should have been like that. I'll just do that for now, okay? I'll call that 3 and this one 2. Right? But they're opposite each other. Okay. So what we can do, we're going to have to, again, we're using a modification of that formula. We need to fix a couple and arrange the rest relative to that couple. Okay. So how many people do I have left to place here? Right? I'm down 2, so out of the 8, I'm left with 6. So there's 6 choices here. Once I choose 6 there, the opposite spouse is gone, and then I have times 4, right? Once that couplet's gone, then I'm down to 2 people left for 48. So there's my answer there. Okay, so basically once you choose a couple, there's 6 left to choose from there. Once that couple's gone, then I'm down 2 people, I'm down to 4. Once that couple's down, I'm down to 2. So that's 48. So I understand that on page 20 there were homework questions. Was it number 3? Number 3, and I thought there was another one on page 20. Show me with your hand. Okay, I'll start with number 3. 3 for now. In how many ways can 8 test questions be arranged so that the easiest and most difficult do not immediately follow one another? So the easiest way to do that is to go, this is page 20, number 3. You have 8 test questions. Easy and hard cannot be together. So the easiest way to do this is to go, this is the indirect method. If we do it the direct way, we're going to drive ourselves crazy. So we'll go total possibilities minus easy and hard are together. Okay, so this is a linear arrangement. It's not a circular arrangement. So if easy, hard are together, there's 2 questions, then 3, 4, 5, 6, 7, 8. I always draw pictures because it helps me. There are 8 factorial ways to arrange 8 questions. Then if 2 of them are together, then there's 1, 2, 3, 4, 5, 6, 7. 7 factorial ways to arrange these questions. But it could be easy, hard, hard, easy. And so that's 2 factorial. And this will be, if we go total possibilities minus when the easy and hard are together, we'll be left with easy and hard not together. Okay, so if we plug that in our calculator, 8 factorial minus 2 times 7 factorial, we get 3240. Now, when you do the questions on page 20, 21, and 22, ignore these questions for now because I will teach this type of question to you in a upcoming lesson. Okay, we need to do the bucket section before you can do these questions, and this one is super difficult, so we'll leave that one for now. But if you could do questions 1 to 12 on page 20, 1 to 11 on page 21, and 1 to 8 on page 22, you'll be in great shape if you understand all of those. 11? Absolutely. Let's look at 11 before we sign off. Here's number 11. 11. Anwar is stringing wooden beads on a leather wristband. He has 12 beads of various sizes and a knot. So the trick to this question is use your knot and arrange the 12 beads relative to the knot. Okay, so let's maybe draw a picture that we have our necklace, and here is a knot, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we have 12 beads. So we can arrange, we really have 13 things, right? So we'll arrange the 12 beads relative to the knot. So it's 13 minus 1 factorial, which is 12 factorial. And that should get you your answer. And that is a big number, 479,000,001,000. Uh-oh, I didn't write that. 479,000, 1,600. Oh, my bad. You're right. Divide it by 2. And I have to divide that by 2. Sorry about that. Thank you for pointing that out. Divided by 2. And we get 239,500,800. You're right, because now we're into something that can be flipped. So we're using this formula here. That's the formula we're using. Good. Anything else I can? Number 9? Sure. How many natural numbers less than 10,000 include at least one 9? So we want, no, sorry, natural numbers. Here, I'll show you the question. How many natural numbers less than 10,000 include at least one 9? So if it's less than 10,000, we're looking at 4-digit numbers. How many natural numbers less than 10,000 include at least one? So we're dealing with 4-digit numbers. Remember, actually it's going to be 4 digits or less, right? 4-digit numbers, they could be 3 digits, 2 digits, or 1 digit. Okay? So that's a little bit different. So what we're going to do is go total possibilities. Minus no 9s. And if we do no 9s, then we will be left with at least one 9. Okay? So if we want all the possibilities with at least one 9, we're just going to go total possibilities minus 0 9s. So total possibilities, we're working with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We're working with 10 digits. But if we're subtracting when there's no 9s, then we're just working with 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, no 9. right? So here we're working with 10 digits. Here we're working with 9 digits. We have 10 digits to play with. Here we only have 9 digits to play with. So this will be 1, 2, 3, 4, 10 times 10 times 10 times 10. If it starts with 0, we have a 3-digit number. If it starts with 2 zeros, we have a 2-digit number. If it starts with 3 zeros, we have a 1-digit number. So here we're going to subtract no 9, so we're down a choice. We only have 9 numbers to work with. So basically we're going 10 to the 4 minus 9 to the 4, and that equals, yep, because if the first one is a 0, we have a 3-digit number. And that's okay in this case. If the first two are 0, we have a 2-digit number. A natural number, some textbooks define it differently, is 1 and up. But then we're subtracting 0, the possibility of 0, 0, 0, 0, 0. It includes the 0, but we're deducting the 0 here. Right? Because if your number here is 0, 0, 0, 0, and your number possibility here is 0, 0, 0, 0, it gets deducted. So 10 to the exponent 4 minus 9 to the exponent 4 equals, I get this, 3, 4, 3, 9. Is that the right answer? No. I'm going to have to take a look at this one again. Oh, this is question 9? Yeah. Yeah, it matches up with the solutions 3, 4, 3, 9. Were there any other questions before I sign off? Yep. 5? Number 5. I'm going to just change the color of this paper because it might be too dark to appear well. So number 5. So number 5. How many 3-digit numbers can be formed using only the numbers 1 to 7? If the number 2 must be included, repetition is allowed. Okay. 1, 2, 3, 4, 5, 6, 7. That's what we're working with. 2 must be included. And they're telling us in number 5, repetition allowed. Those are the important things we have to worry about. Well, the easiest way to do this is to go the indirect method, where we go total possibilities minus 2 not included, and that will give us at least 1 2 included. Okay, so we have, let's see, they want, how many digit numbers do they want in number 5? 3-digit numbers. Okay, so it's going to be total possibilities is going to be, we have 7 numbers to play with, right? They can repeat, so it's not like I'm going 6, 7, 6, 5, because they can repeat at 7, 7, 7. I'm going to subtract where 2 is not included. So if 2 is not included, then I only have 1, 2, 3, 4, 5, 6 numbers to play with. So it's 6 times 6 times 6. And that will give us our answer. If I can find my calculator. Oh, I found it. I get 127. Is that good? Can you think of anything else before we move on? All right. Awesome.